Good morning, everybody, and welcome back. We are on day 2 of our fascinating trip through land surveying. And last week we had a really big day. We covered a lot. We talked about the exam itself, what to expect on exam day. And one of the things when we went over the requirements for the exam is there's probably about 25 to 30 questions on mathematics. So we had a quick little, about a 2-hour review of math. I hope that was good for you guys. I always have to brush up on that stuff myself, believe it or not. I studied for about a week before class because, like I said during the lecture, a lot of that stuff we just don't use on an everyday basis. So. We also talked about field data acquisition. We finished up last week in chapter 15, and chapter 15 talks about traversing, and we got about halfway done with that, so we'll finish that up this morning and then go into the new material. Today we'll be talking a little bit more about plane survey calculations, and this is really the main reason I became a surveyor, because I love problem solving. When I worked at Santa Ana College, I was on staff there for 8 years, and I taught a class called Advanced Survey Problems. Do they still have that in the curriculum? Okay. I don't know who teaches it now, but I taught that class for 8 years. Loved that class. All we did every week was solve problems over and over and over again, and I gave a quiz every week on the previous week's material. If we solved problems on vertical curves, the following week we'd have a quiz on vertical curves at the beginning of the class. Love that class, and we'll be talking more about that today, survey calculations. We're also going to be talking about GPS, the Global Positioning System, and how we use that in surveying. The system itself was originally invented for use of the military. The Department of Defense put the whole thing together for military use. There was a couple really smart people that said, hey, I think we can use this for land surveying. And we'll talk about some of the history involved there. We're also going to talk about geodesy. Remember, there's 2 kinds of surveying. Plane surveying, P-L-A-N-E, where we assume the world is flat. And if we're working in a relatively small area, we can do that. But if we're working in a large-scale project, like many times we do, we have to take into consideration the size and the shape of the Earth, and that's called geodetic survey. So we'll learn a little bit about that today. And then we'll finish up talking about mapping, topographic mapping. And we'll talk about topographic mapping, doing a conventional survey, using a total station and data collector, and we'll also talk about doing it using photogrammetric methods, all right? One of my favorite topics of surveying is photogrammetry. I was a contract administrator for the photogrammetry section for Orange County Public Works. I think I had that job for like 4 or 5 years, so I got to know all the photogrammetrists in the area, and I got to go up and fly in the plane and take pictures and go back to their shop and see how they did their work and stuff like that. Really a fascinating part of surveying. And we'll learn about that today. And next week, we'll have our guest lecturer, Mr. Tony Como, come in. His specialty is public lands and boundary surveying. And he'll be doing most of the day next week, and I'll be finishing it up. And then on the last day, we're going to have a test. We're going to have a practice exam that is very much like the real thing. The only difference is it's going to be on pencil and paper. It is multiple choice. It's a 3-hour exam, multiple choice. We'll do that in the morning. We'll come back in the afternoon. I'll go over the exam when you see how you did. There's only one way for you and I to know how you are perceiving this material that I'm putting out. And you know what that is? To test. That's the only way. You can sit there and say, yes, I have it. I understand, John. I totally got this stuff. But the only real way to know is to test you on it, so that's what we're going to do. Now, some of you are not going to do so good on the test, all right? It's a hard test, because it's just like the real thing. It's really hard. I mean, people are like, whoa, all right? But if you're going to do badly on an exam, I want you to do badly here with me because it's a learning experience, all right? So don't be too hard on yourself if you don't do so well. The important thing is when you take the real exam that you do great, all right? And how many are ready to do great on the real exam? Raise your hand. Yes, all right, fantastic. Okay, let's get started again. Before we do, are there any questions about anything we talked about last week? Any questions at all? It looks like most of you got your textbook, right? That's good. You know, I was looking on Amazon and I actually saw some used books for $60 or something like that. I was actually going to send you guys an email, but I couldn't find your email list, or they have it at the school, so if I find another deal, I'll let you know. All right. Okay, let's kick it off on chapter 15, page section. The book doesn't have pages, which bugs me. It's got sections and pages. 15-8 is where we're going to pick it up. Okay, I think this is where we dropped off last week. We talked about the error of closure. The error of closure. What we're going to do there is to calculate the difference in the beginning coordinates and the ending coordinates, and then we're going to make a ratio using that error of closure to the perimeter of the traverse, and that's going to give us the accuracy of the traverse. Now, in the handout that I gave you this morning, let's see, where is that? Alex, I don't know if he put that up here. Alex, are you there? Come on in here, will you? The handout that I gave you this morning on, let's see. Okay, did you post that up on the thing here? Which one is it? What do you call it? Oh, workbook pages. Okay, all right. Okay, here we go. So the handout that I gave you this morning, I want you to look at. Let's see, where is it? Here it is. There's one at the top, and this is from different books, so there's no page numbers, but at the top it says B18. Okay, and over here on the right side, you'll see it says classification of control, all right? So when you do that traverse closure to calculate the accuracy of it, all right, what do we do with that, all right? This is what we do with it. We see if it meets specification. Now this is a specification set up by, you see what it's called, the Standards and Specs for the Geodetic Control Network by the FGCC, the Federal Geodetic Control Committee. That's a committee within the National Geodetic Survey that we talked about last week. We talked about NGS last week, right? NGS and USGS, as I recall. Okay? So here you'll see that for horizontal control, and when we're talking traversing, that's exactly what kind of control we're talking about. This is the accuracy, okay? The accuracy, if it's a first order survey, it's 1 in 100,000, pretty tight, all right? That means you could measure 100,000 feet. That's about, what is that, about 17, 18 miles, okay? And be off plus or minus a foot. That's pretty good work. That's pretty good work. That's definitely first order stuff, and that's not the stuff that we do every day for sure, all right? But when you're doing first order control work for horizontal control system, like the county surveyor does, like the National Geodetic Survey does, you do work to that stringent standard right there. Okay, second order class 1 is 1 in 50,000. Second order class 2, 1 in 20,000, and so forth, all right? Usually the stuff that we do on an everyday basis using the modern equipment and methods that we have today, getting a closure of 1 in 20,000 is usually not a problem. Okay. Now this kind of thing is kind of becoming a little bit passé. You'll note that a lot of times now people will want error ellipse. Okay, have you guys done that? You have an error ellipse and it'll show like where within that ellipse your point falls. Okay, and the bigger the error ellipse, of course, the less accurate it is. Okay, so that's another way of defining accuracy. So this is a little bit old school, but still used today. I just want you guys to be familiar with this and know what it's used for. So I gave you a copy of that so you know some of the specifications. Now, if, for example, your specifications state that all traverse work should close within 1 in 20,000, okay, and your raw field data does indeed close 1 in 20,000, should you just leave it at that? No. You want to adjust it, okay? You want to adjust it so that closure is perfect. And the most common adjustment that we use is called what? Compass adjustment, okay? Compass adjustment. We'll learn about how to do that today. The other one that you'll hear, there's a couple more that you'll hear, the Crandall adjustment and the transit adjustment. Those are both kind of old school, and those were dependent on angular measurement being more accurate than distance measurement. When we talk about the compass rule, distances and angles are given equal weight. Okay. Another one that you may have used for adjustment is called a least squares adjustment. All right. There's a program for that. A lot of people use a program called StarNet. Anybody ever use StarNet? Okay. That's a least squares adjustment. And basically what a least squares adjustment does is this.